We would like to take this opportunity to go over some troubleshooting tips for your MistFree series humidifier. Any troubleshooting done in the MistFree series will require you to remove the fan cover to get at the interface plate beneath. You can remove the fan cover by removing the 6 thumb screws, 3 on each side, and removing the fan cover itself. Note the 3-foot cord between the humidistat and the terminal block. Be sure not to pull or strain on this cord. The 3 main tools you'll need to troubleshoot a unit is a multimeter or voltmeter, the wiring diagram located on the stainless steel vertical, and the serial number located on the center of the vertical. Humidifirst will not be able to assist in troubleshooting without the unit's serial number. The 3 most common problems encountered are the humidistat is not reading correctly, the unit is not producing humidity or mist, or the unit is overflowing with too much water. Let's look at them one at a time. A common troubleshooting scenario can be the humidistat not reading correctly. Your humidifier will not be able to maintain your desired humidity level if the humidistat cannot read correctly. In this example, we have a relative humidity of 67.4%, but the humidistat is reading 86.5%. The most common cause of this is user error, or calibrating the humidistat incorrectly. The humidistat should always be calibrated to 0%. To calibrate a humidistat, hold the dot button down for 3 seconds, and you will see SELCALT, that's Select Calibrate Temperature. If you hit up, it'll say Select Calibrate Humidity. Press the dot button. Right now it is set at 15%. This means the humidistat will read 15% above its measure. Again, a humidistat should always be calibrated to 0%. Once calibrated, press the power button 3 times to reset the humidistat. Turning the humidistat back on, you will see our reading of 68.3 and 71.5, much closer. Note that 2 relative humidity sensors will almost always read slightly off. This is just the nature of relative humidity sensors. If you ever see an Error 1 message in your humidity reading, this means the actual humidity sensing chip in the humidistat is failed, damaged, corroded, and is no longer useful. You can remove the small set screw at the bottom of the humidistat to remove the faceplate. You will see the humidity sensor chip in the bottom of the humidistat. This is meant to be replaceable for this scenario. Note, relative humidity is relative to temperature. If your humidistat is located where a heating vent or air conditioning vent can blow directly at it, this will affect your measurement. Be sure your MistFree is located in a position where it can take an accurate measurement of the space and room you want to maintain. The most common troubleshooting scenario is the unit's transducers not operating, or the unit does not produce mist vapor. If you hear your humidifier running, but the relative humidity in your space is not increasing, this may mean your transducers are not operating. The easiest way to verify the transducers is to visually inspect the water pan while the unit is operating. Turn your unit off and remove the fan cover and chute to get at the water pan. Restart the unit and make sure the set point on your humidistat is higher than the relative humidity reading. We will now show you operating transducers. Each transducer should have a 2 to 3 inch fountain or finger of water off of it, and the mist would roll off that fountain. All transducers should be operating at the same time in a uniform pattern. Another scenario that can keep the transducers from operating is low water or not enough water supplied to the humidifier. Note the humidistat is on and calling for humidity, but the transducers are not operating. This is because there's not enough water in the water pan for them to operate safely. Inside the small metal housing is a two-stage float. When the float reaches a first mark, it communicates to the solenoid to refill with water. If the float hits a secondary low mark, it cuts power to the transducers so that they cannot operate without the proper amount of water on them. Activating the water line will show the humidifier refilling with water. Once the humidifier reaches the necessary amount of water, it will allow the transducers to operate again. If the water was to be shut off or interrupted to the unit would shut down completely. In a scenario where you have an undersized RO reserve tank or undersized water treatment system that can't provide water to the humidifier fast enough, you can create a scenario where water trickles into the unit. This will sometimes allow the float to be in the position to allow the transducers to run, and sometimes not. And the unit can go back and forth and chatter between operating and not operating. Or the float can reach just the level to allow the transducers to operate, but not allow it to fill up to its prime level. These scenarios can actually stress and damage transducers. You always want to make sure you have a full and proper water supply to your humidifier. And again, once the unit fills up to the proper level and the float reaches its top position, the transducers will turn back on. Another common troubleshooting scenario is a blown fuse. Humidifirst suggests verifying if a fuse is good or bad by reading the voltage across it. Sometimes a fuse can blow and still allow continuity, so just reading continuity will fool you. Let's take a minute to look at the transformer and talk about the power structure inside the MistFree system. On the transformer, you will see a primary side with a black and white wire, and a secondary side with an orange, red, and blue wire. The primary side of the transformer is the incoming power, in this case 120 VAC, although 230 and 480 are available. The black wire is the incoming 120, and the white wire is the neutral. You can verify this with a voltmeter or multimeter set on AC. Simply take your prongs to take a reading across the black and white, and you will see your 120 VAC. On the secondary side of the transformer, you must use the secondary neutral to get an accurate reading. In this case, we'll take a 24 volt reading on the red wire and a 48 volt reading on a blue wire. Taking a reading on the secondary side of the transformer against ground will not give you accurate readings. We'll show you this now when the transformer is drawing. As you can see, when the transformer is drawing, you cannot get an accurate volt reading to ground. When reading the secondary side of the transformer, always use the secondary neutral to take your power readings. The same rules apply when looking at the fuse block. Black is 120 on the primary side of the transformer. Blue is 48 volts on the secondary side of the transformer. And red is 24 volts on the secondary side of the transformer. To verify a fuse is good, use your corresponding neutrals on the transformer as discussed. To check the 120 volts, we will use one prong on the transformer's neutral on the primary side. Check the incoming power of the fuse as 120. Check the outgoing power of the fuse matches 120. On F2, the incoming power is 120. The outgoing power is 120. When checking your secondary fuses, be sure you're using the secondary or orange tap on the transformer to get an accurate reading. In this case, we have one prong on the secondary neutral and can check the 48 volts coming in, the 48 volts going out, and on the 24 volt fuse, we can see the 24 volts coming in and the 24 volts coming out. In the scenario of a blown fuse, we would see the 48 volts coming in, but no voltage coming out. This would tell you that that fuse is blown. Check the wiring diagram attached to your unit for all fuse ratings. These fuse ratings must be followed for your system to work correctly and be protected safely. The MistFree system also utilizes two surge arresters in conjunction with its fuses. There is a surge arrestor for the 48 volts located across terminals 1 and 2, and there's a surge arrestor for the 24 volts located across terminals 21 and 22. A surge arrestor protects the circuit in the event of a power surge. If too much voltage comes through the circuit, the surge arrestor will arrest and create a short, blowing the corresponding fuse. If you have a blown fuse that you replace with a new fuse, and this new fuse immediately blows, you're going to want to check your surge arresters, as that is likely the culprit. To check a surge arrestor, it is best to remove it from the terminal block. To remove it from the terminal block, you will notice the small slits just above it. Using a small tech screwdriver, insert it into the block, and you can remove each side of the surge arrestor. Once you have the surge arrestor removed, we can check it. To check a surge arrestor, you want to check for continuity across it. A good surge arrestor will not have continuity across it. When a surge arrestor is blown, it creates a short or continuity across it to blow the corresponding fuse. If you take your voltmeter or multimeter and set it on continuity, you can place one prong on each side of the surge arrestor. A good surge arrestor will not have continuity across it. Sometimes the simplest solution is the correct one. A loose wire can keep a relay from being energized and the system from working correctly. This can sometimes happen on a brand new system, as sitting on a truck during shipping can loosen electrical connections. When starting up a new system or troubleshooting a system not working correctly, it's a good idea to just check the tightness of each electrical connection, as all it takes is one small loose connection for the system to not work correctly. A failed or damaged component will also not allow your system to operate correctly. Looking at the MistFree's interface plate, you'll see the fuse block, the R2 relay, the R4, the R1, the R3, and the terminal block to connect the wiring. The transducers are controlled by the R1 and R3 solid-state relay. When the transducers are operating, both these relays should be lit green. If your transducers are not operating, also check these relays to see if they are lit. If one of these is not lit, you can follow your wiring diagram or contact Humidifirst to investigate why. The final test for transducers not operating is to verify the transducers themselves are receiving 48 volts AC. If your humidistat is calling for humidity, you verified your transformer power is good, your fuses are good, and the solid state relays are both lit, your transducer should be receiving 48 volts AC. You can verify this on terminals 1 and 2 and 3 and 4. Terminals 1 and 2 power row A, terminals 3 and 4 power row B. The small openings in the middle of the terminal blocks are used to make contact with the circuit. Having your voltmeter set on AC, we can take a reading at terminal 1 and 2 and see our 48 volts. We can take a reading at 3 and 4 and see our 48 volts for row B. If these terminals are powered by 48 volts and your transducers are still not operating, the transducers themselves may be failed.